Hey guys, my name is Paisley and I'm a 6th grade science teacher in San Diego, excited to walk you through Amplify's Thermal Energy Unit. This unit is an essential precursor to the Earth Science units, so thank you for taking the time to prepare yourself for an awesome unit. The big question that this unit drives towards is, why do things change temperature? Although the sensory experience of temperature is intuitive, temperature changes can be explained by the movement of molecules, which facilitates the transfer of kinetic energy from one place to another. But before we begin, make sure you've read and annotated the unit overview, unit at a glance, and standards, as well as the science background knowledge. Grab a pen and your unit internalization guide, and we're ready to begin. So why does thermal energy even matter? Temperature is a fundamental part of human life. From the daily highs and lows reported on the news to the settings on an oven, temperature measurements are ubiquitous, reflecting the important role that temperature changes play in one's experiences of the world. In their role as student thermal scientists, students work with the principal of a fictional school, Riverdale School, in order to help the school choose a new heating system. They compare the system that heats a small amount of water with one that uses a larger amount of cooler groundwater. As they analyze the two heating system options, students learn to distinguish between temperature and energy and to explain how energy will transfer from a warmer object to a colder object until the temperature of the two objects reaches equilibrium. Chapter 1 starts off by asking, what is happening when the air in the school gets warmer? Students start off the unit with a lab that investigates the movement of food coloring in warm and cool water. Then students investigate molecular movement and temperature in the sim, and by reading about the idea of absolute zero, the point of coldness in which all molecular motion stops. They create visual models showing the difference between a substance when it is warmer and cooler by using some recurring symbols which they catch on to really quickly. By the end of Chapter 1, students have discovered these three main key concepts. The temperature of an object is related to the kinetic energy of its molecules, which increases as the speed of the molecules increases. Hotter things are made up of faster moving molecules, which have more kinetic energy. And colder things are made up of slower moving molecules, which have less kinetic energy. This sets them up for the first chapter focus task. What is the Chapter 1 focus task assessment? So glad you asked. In this task, students are asked to model the difference between molecular motion in colder air and warmer air using the cue provided. Then they simply explain their thinking in an open response. Go ahead and pause here to try it on your own. All right, thermal energy scientists, how did you do? Students should illustrate and explain that colder air has slower moving molecules. So far, so good. In Chapter 2, we explore what causes the air molecules inside the school to speed up. We start by watching a video of an investigation in which a container of warm water heats the air around it, and they explore one thing warming another in the sim. They read how air conditioning makes cities hotter, and they examine molecule collisions during energy transfer in the sim. Students start to put together how a hot thing and a cold thing can impact each other on a molecular level, such as why a cold washcloth can cool you down when you have a fever. They also read another article focusing on these molecular collisions, likening it to a Newton's cradle. Lastly, students model energy transfer between objects using these little yellow cubes, which represent energy in a physical model. By the end of Chapter 2, our scientists can now explain that warmer objects transfer energy to cooler objects when they are in contact. The transfer of kinetic energy causes faster moving molecules to slow down and slower moving molecules to speed up until all of the molecules are moving at about the same speed. The Chapter 2 focus task is a more complex version of the Chapter 1 task. Now, students are challenged to demonstrate that warm water and cooler air in the school will reach equilibrium by the end of the day. They are also challenged to explain this phenomenon by challenging a claim and using specific vocabulary in their answers. Pause here and try it out for yourself. So, if you are as sharp as our students, you showed that the energy in the morning is transferring from the warm water to the cooler air. You also illustrated in the model that by the afternoon, energy transfer has stopped because the air and the water have reached equilibrium. Note, Amplify's answer key is not looking for a specific molecular speed. We just want to make sure that kids are demonstrating equilibrium by having the same speed in both the air and the water. Pause here to review the exemplar student responses for the written response portion. In Chapter 3, In Chapter 3, we will finally get to answer which heating system will warm the air in the school more. Students read about the size of objects, the number of molecules, and energy transfer in the article, Thermal Energy is Not Temperature. This is a main centerpiece for this chapter. Students test energy transfer using objects of different sizes with the physical models again, and we replicate the same idea in a class demo using different volumes of water. We come back to our two heating systems and collect some final data before constructing an explanation of which heating system is better for the school and why. We find out that water system 2, using the larger but cooler water tank, will reach a higher equilibrium temperature and therefore is a better choice for the school. The Chapter 3 key concepts are all about size. The size of objects in contact affects the amount of energy transfer between them and the amount of temperature change. Larger things are made up of more molecules than smaller things. Changes in temperature are affected by the number of molecules of a system because kinetic energy is distributed among all of the molecules in a system. Now that we know the second heating system is more effective, the Chapter 3 focus task involves students using evidence to support that claim. Given evidence cards, they complete a reasoning tool explaining why that evidence is relevant. An example of what this might look like is this. Students used an evidence card recapping our class demo to reason that something that is made up of more molecules has more total kinetic energy that it can transfer, and it will reach a higher equilibrium temperature. And that is why the groundwater system is more effective. Now that students have a strong foundation in thermal energy and energy transfer, we get to apply this to a new scenario. In this case, we need to figure out why wasn't the water pasteurized. Kits for pasteurizing water were distributed to help victims of a natural disaster heat water and make it safe to drink, but some people still got sick. Was this because of a problem with the kits, or because some people did not follow the instructions? Students analyze evidence about temperature, mass, and energy transfer in order to make their arguments. They engage in oral argumentation in a student-led discourse routine called Science Seminar. After the Science Seminar, they write their final arguments to answer the question, why wasn't the water pasteurized? Pause here to read the prompt more closely. Students have the opportunity to support Claim 1 or Claim 2 as long as they have supporting evidence. Pause here to read some of the examples of what these final arguments may look like. Let's go through one example of each progress build question to get a sense of what will be asked on the end of unit assessment. This is an example of the progress build 1 question. Pause here to answer it on your own before moving on. Don't cheat. How'd you do? The correct answer is C. We know this from our progress build 1. Hotter things have faster moving molecules and contain more energy. Here's another chance. Our progress build 2 question is a little bit longer. I'll give you a chance here to pause and try it out. Congratulations to those of you who chose A. This question is not just about which way the energy will transfer, but when the energy transfer will stop as well. Energy transfers from hotter to cooler things and will stop once the temperatures are equal. Okay guys, this one is hard, but I know you can do it. Pause here and carefully try it out on your own. Drum roll, please. The answer is B. Energy transfer has a lot to do with the size of objects, as we learned in Chapter 3. Bigger objects made of more molecules will have energy transferred over many more molecules than smaller objects, which is why it will be cooler. How are you feeling so far? The bar is high for students, isn't it? Let's look at an example of a constructed response. Take a few minutes to pause here and jot down what you think. Amplify's rubric guides you through what we'd see from students at different progress builds, but ideally we want them to be here. The student demonstrates an understanding of levels 1 and 2 content above and explains that the number of molecules in an object determines how much it will change temperature for a given energy transfer. Take a moment to read the student response before moving on. You did it! You just went through an entire Amplify unit in less than 10 minutes. Thank you for taking the time out of your crazy schedule to prepare yourself. Our kids definitely deserve it. KIPP teachers, please complete the following final steps and you'll be good to go. Thanks for watching.